So what's up, people? I believe everybody is doing great, nice, and absolutely fine. I just want to know if we are live right now. Yes, I hope so. Okay. 1 second, I just need to check. And it's been a long time. Still, my inverter is not working. UPS is not working. Okay. The technician will come by tomorrow itself. And from day after tomorrow, most probably, we'll be starting our one-shot series. 1 second, man. Some So, people, I just want to know if we're live. Yes, we are live. So, what's up, everybody? Is everybody doing great over here? Okay. I hope so. So, people, what's going on? And I welcome you to JEE English Academy. Yeah, good evening. Good evening. Is everybody doing great, nice, and absolutely fine? Ladies and gentlemen, I welcome you to JEE English Academy. And in the today's session, we're gonna be talking about some of the MCQs, understand, which are gonna come in your CBSE term for sure. Okay. And apart from that, I just want to tell you one thing. My UPS is still not working. It will work. The technician will most probably come by tomorrow itself. So from day after tomorrow, we'll be starting our one-shot series as well. So till then we have to wait. So I thought of I can take this session because my UPS is exactly giving 35 minutes backup only. Okay. So I cannot take 5 hours long session right now unless this issue is basically resolved. So ladies and gentlemen, let me just tell you about myself. My name is Yawar Manzoor and I'm a JEE physics expert. I welcome you to JEE English Academy. If you haven't subscribed yet, just hit the subscribe button as soon as possible. Okay. Yes. So let me just tell you that my name is Yawar Manzoor. Okay. This is my username on Unacademy. You can hit the follow button as soon as possible in order to get the notifications every single time whenever we basically come live, whenever we take the special classes. Okay. Keep this thing in your mind. Next thing over here is, if you people want to learn from the country's top educators, if you people want to take your rank to the next level, you are supposed to come onto our own platform, that is Unacademy's own platform. Okay, Unacademy's own platform. Now, you might have recently seen what Unacademy has produced in JEE 2021, like AIR1 was from Unacademy, 18 was from Unacademy, 87 was from Unacademy. Definitely, you should go for this plus subscription if you people want to basically fall in that category. If you people want to take your rank to the next level, so this plus subscription is for you. This iconic subscription is for you. What are the benefits that you can get in this plus? The first one is that is nothing but live classes. You'll be getting live classes every single day, weekly tests. Once you are done with the entire stuff that you have studied for the entire week, afterwards you'll be getting this weekly test. Then you will be having the structured courses and unlimited access as well. Okay. Now, if you take this iconic subscription, you'll be getting personal guidance. This personal guidance is personal mentorship. Personal mentor will be given to you. If you need any sort of clarifications on anything, he'll be guiding you throughout your exam. Understand? And test analysis. Once you are done with your test, afterwards you have to analyze your scores. In what portion you are lagging in what portion you need to work more so that you will get the better scores in the upcoming time. Okay, this is what we call the test analysis. And experts guidelines. Okay, I feel without the proper guidelines, proper plan, proper strategy, it's almost impossible to crack JEE Advanced. So for that, these guidelines are highly mandatory. Study material. Okay, this study material will be sent to you to your doorstep from Unacademy if you take this Iconic subscription. Okay, yes, and study planners as well. Okay, and this is definitely not my code. I forgot to change it. My code is basically this, Yawar. Okay, this is my code in capitals. Okay, use this code if you take any of the subscriptions like Plus or Iconic. If you take the Plus subscription for 30 months, for 24 months, for 12 months, for 6 months, the prices are mentioned over here. This is the price, this is the price. Now the point is the EMI option available? Yes, definitely you can pay it monthly as well. You don't have to pay the entire amount at once. You can pay it monthly. Same goes for the Iconic subscription as well. Okay, these are the benefits you get in this Iconic and Plus subscription. This you can definitely go for this one, and these are the prices over here. Next thing is these are the batches which we have recently launched on Unacademy. These are the batches which we have recently launched on Unacademy. So definitely you should go for these batches if you people want to take your rank to the next level. So go for these batches as soon as possible. Next thing is this is a T20 test series. Okay, this is for 2022, 2023 for aspirants. Now, if you get the rank 1, you will be getting 5,000. From 2 to 6, 3,000. 7 to 20, 2,000. Use my code Yawar in order to get the maximum possible discount. Okay, this is my code Yawar. You need to basically use this while you enroll in this one. Keep this thing in your mind. Next thing is you can win up to 4 crore plus scholarship rupees. This is what we call the Unacademy Combat, Mega Combat. If you're looking like you want to learn free on Unacademy, you should definitely go for this one. Use my code Yawar while you enroll in this one. Okay, use my code Yawar. Understand? Next thing is we have this beautiful feature that's ask a doubt. You can ask any sort of doubt if you have. You can ask the unlimited number of doubts. Ask the doubt any damn time. You'll get the high quality video solutions and you'll receive the exact match. This is how you can exactly ask the doubt. Make sure the image is very clear, neat and clean. Crop that particular doubt for which you need the particular answer. And the next thing is these are the MCQs that you can expect in your upcoming CBSE Term 1 exam. Okay, this session is for those people only. The first question on the screen itself, I want you people to basically read out all of these 4 options over here and tell me what is the correct option exactly. Okay, this is from the electric flux. This MCQ, come on, A, B, C, D, which option is the correct option? I just want to know the answer in the live chat itself, all of you. Okay, that's great. Come on, I just want to know the answer in the live chat. A, B, C, D. Which option is the correct option? Everybody. Okay, people saying A, C, A. C. Let's see what's gonna be the correcto optional. D. Okay. Now see. What exactly the question is exactly saying over here. Listen to me very carefully. We can just solve it in 5 seconds. Okay, that's all. But you should know the concept behind this. That's all. Listen to me very carefully. I'll just tell you the concept behind this. For example, if I say this is a surface, okay, this is a closed surface. Understand? And inside the surface, I am placing a charge Q1 and this is the charge Q2 over here. Fine. And there is this charge exactly Q3. Fine. And if I use the Gauss law in this one, what does that say? If there is a closed surface, inside that surface, if I am placing any sort of charge, what will be the flux through that surface? You will say, sir, according to Gauss, it is nothing but Q inside upon epsilon naught. Understand? This is the flux through that surface. This we have studied till now in our Gauss law. Fine. Now, could you please tell me over here? You'll say, sir, in this case, if we use the Gauss law, can I say in that case, flux is what? We say flux is also that is E dot dA, integral of E dot dA. Understand? If we take the small element over here, dA element, I hope you have studied this one. So in that case, if I say integration of this dot dA, E1 dot dA will be equal to, that is Q1. Understand? Because Q1 is the charge inside in this case upon epsilon naught. Can I say it like this? So then integration E2 dot dA, same another, I'm taking the second element over here, dA element, electric field, this is E, this is a dA. And in this case, you'll say, sir, that is nothing but Q2 by epsilon naught. This is the charge inside. Flux produced by this charge, that is inside this one. This is the flux produced by this charge. This is the flux produced by this charge, E dot dA, E dot dA, number of field lines passing the surface. So, and could you please tell me what is this one? You'll say, sir, E3 dot dA will come out to be nothing but it is 0. Why 0? Because this charge inside in this case is nothing. Understand? No charge. The Q3 is basically outside this one. So can I say Q inside in this case is 0? Because this is what? Q1 is Q inside. Understand? We are taking this as the charge which are enclosed in the surface. Enclosed in the surface. Okay? Yes. We are taking this charge which is enclosed in the surface. So if I ask you to tell me the net flux over here, you will say, sir, that is nothing but E1 plus this E2. You can put the vector as well. Plus this E3. Okay? Dot dA. Okay? Take this, dA will be equal to. What is the contribution? You will say, sir, that is Q1 plus Q2 upon epsilon naught. That is Q1 plus this Q2 upon epsilon naught. Just remember this thing. This is the concept behind that MCQ. Listen to me very carefully. Can I say from the left side of this equation, from this side, we say this is RHS, LHS, this side, okay? On this side, can I say the contribution is because from all the three charges, this one, definitely yes. And on the right side, this side, whatever the side this is for you people, okay? You can say, sir, on this side only we are saying that the charges which are inside this closed surface, only they are contributing in this equation. So that is Q1, that is Q2, because Q3 is outside the surface. So we say, if we use this is a general equation, for this equation, in this equation, from the right side we say Q1 and Q2 are contributing, and from the left side all the three charges are basically contributing. Same is the case exactly over here. Listen to me very carefully. If I say, for example, this is over here, that is nothing but Q4, and this is Q2, this is Q1, this is Q3, this is Q5. Okay? Now, in the first question, it is saying that exactly, if we use the same formula over here as well. So what is the charge inside this closed surface? You will say, sir, Q4 and Q3. So can I say on the right side, Q4 and Q3 will basically contribute. Understand, flux will be through Q4 and Q3. And I would say, in this case, because of this one, the field lines entering the surface will be equal to the field lines leaving the surface. I can definitely say it like that. Same goes over here. So can I say field line will be because of, flux will be because of this one, flux will be because of this one. Now in this case, read the options. It is saying that E on the LHS means this side of the equation, So E on the LHS, electric field on the LHS of the above equation will be contributing from Q1, Q5, Q3. No, all the charges are basically contributing to electric field if I talk about. See, all the charges over here, 3 also, 1 also, 2 also, all the charges. But on the right side, only those charges are contributing which are inside this closed surface. So option A is basically incorrect. Option B, let's have a look on the option B. E on the LHS of the above equation will have a contribution from all the charges. Yes, all the charges. So can I say from all the charges? In this case, if I write the same equation over here, you'll say, sir, that is E1 plus this E2 plus this E3 plus this E4 plus this E5. Okay? And this will be dA, will be equal to, that is Q inside. This is net electric field multiplied by this dA is equal to Q inside. How much is the Q inside? You'll say, sir, that is this Q2 plus this Q4 upon epsilon naught. Can I say it like that? On the left side, all the charges are contributing, correct? And on the right side, what are the charges contributing? You'll say RHS will have a contribution from Q2 and Q4 only. Definitely, this is the correct one. Wrong. Understand? This is the concept behind this. Everybody, you got the feel of this one? Okay, that's great. Thank you, man. Means a lot. Now, we have the next question on the screen itself. I just want to know what is the correct answer for this one. Come on. The electric field intensity at a point situated 4 meters from the point charge is this one. Electric field intensity is given this one. If the distance is reduced to 1 meters, the electric field intensity will be. Electric field intensity will basically increase in this case, okay? It will increase in this case. If I say, first, these are the two charges according to the question. This is the charge 1, this is the charge number 2. Okay? Could you please tell me what is the electric field intensity in this case? Between this and this, for example, they are saying the distance between this is 4 meters exactly. When the distance between this and this is 4 meters, they are saying it is 100. So 100, we say E is equal to, that is KQ by R square. So we'll say, sir, that is 100 is equal to KQ, Q. This is KQ, understand? This is not because of this charge I'm talking about. This is not the force. Okay, because of this charge at this point, I'm asking you to tell me the electric field intensity at 4 meters. Said, sir, that is 100 is equal to KQ by R square. R is, that is 4 square over here. Can you tell me what is the value of KQ? You will say, sir, that is 4 square 16 and this will be 1600. Okay, fine. In the first case, yes. This is a good channel, okay? Why do you say? Okay, now, if for example, we have reduced this distance, okay, to 1 meter exactly, we have reduced to 1 meter. In that case, could you please tell me what is electric field? You will say, sir, E is equal to KQ by R square. At any point, electric field is KQ by R square. You will say, sir, that is KQ by R square, that is 1 square. So in this case, this KQ will be equal to E. Same charge we are taking, but we are reducing the distance. So K will be same in the same medium. So KQ is this, equate this one. So can I say this E will be exactly equal to, this is 1600. Okay. Come on. Let's move on to the next one. Yes. Let's move on to the next one. Can you guys tell me what is the correct option for this one? Okay, there are 3 positive charge of equal value Q, okay, are placed at the vertices of an equilateral triangle. The resulting lines of force should be sketched as in option A, B, C. Which option is the correct option? Okay. I like to teach in English only, that's why. I don't want to go to some Hindi channels because there are tons and tons of educators who are teaching in Hindi. Okay, D, you're saying D? That's great. Some people saying C. D. Most of the people are actually saying D. Listen to me very carefully. If I say, for example, this is a charge. This is a question from electric field lines. Okay, this is a charge over here. This is another charge exactly over here. Fine. Now, if I ask you to draw the electric field lines in this case, first of all, let me just show you for positive charge and negative charge. Okay, we say field lines start from positive charge and they end at negative charge. So it will be something like this. They start from positive charge and they end at negative charge. They start from positive charge and they end at negative charge. It is something like this. Understand? Now, some field lines may go something like this. They will go till infinity. They will go till infinity. And these field lines will exactly come from infinity. They will come from infinity and will enter this Q. It is something like this. This field line is going from this side and it has to be symmetric. Number of field lines from the upper side will be equal to number of field lines from lower side. Okay, number of field lines from the upper side, this has to be symmetric. So we say these lines are, for example, going till infinity. The direction should be exactly something like this. You need to mention the direction as well. From positive to negative, from positive to negative. And this is entering the negative, this is entering the. This is the case between positive charge and negative charge. And what happens with the negative charge only? What happens with the 2 positive charges? See, the 2 positive charge, it has to be something like this. It has to be something like this. It has to be something like this, okay? So It has to be something. They are basically repelling. Two positive charge basically repel. The electric field lines will be something like this. So in the first case, this is a positive charge over here. This is a positive charge over here. This is a positive charge over here. Line is going from positive to positive. Is it possible? Definitely not. Line goes from positive to negative. So definitely this is not the correct one. In this case, it is showing that this line, what is this line over here? Definitely this is incorrect. Okay. So this has to be the correct one. This is the correct version of this one. This is the correct version of this one. Can definitely show it something like this as well. Fine. Third option is also incorrect. What is this? Okay. Making the circles, making the rings over here. So fourth option is basically the correct option in this one. Okay. Yes. Yes, I'll be taking the electrostatics one shot most probably day after tomorrow. Seriously, I'm not lying, I swear. My inverter is not working. It is giving the maximum of 30 minutes backup. So electrostatics one shot will be for 5 hours, okay? So it is not possible if I start this and in the middle of the session, it will go down. So entire this, so that's why, understand? For sure, I'll be taking it. So tomorrow the technician will come. He'll set it up everything over here. Once this issue gets resolved, definitely we'll start with the one shots. Most detailed, okay? And with JEE Advanced, all the JEE Advanced previous year questions. Next question we have on the screen over here. The force between two charges is 120 Newton. If the distance between the charges is doubled, the force will be. What happens with the force? Come on. Yes, I'll take all the 12th chapters as one shot, as well as I'll take all the chapters for 11th class as one shot. Okay, but we have to finish the 12th class first, then we'll move on to this. Yeah, that's great. F by 4. Okay, so in this case, you tell me one thing. If, for example, we say these are the two charges, understand? These are the two charges. The question is basically saying the force between two charges is 120 newtons if the distance between is doubled. If we increase the distance, this is the charge, this is the charge. What is the force between these two charges? For example, it is something. If you double the distance, how much will be the distance? How much will be the force reduced? Come on, everybody, I just want to know in the live chat, what is the correct option? A, B, C, D. Come on. Come on. I'm just waiting for you. Yes, Surya is saying 30 newtons. That's great. That's great. B. Okay. Now see, how do we exactly solve this? This is a basic question. If I say, for example, F is equal to 1 by 4 pi or K Q square by R square. Okay. 1 by 4 pi epsilon naught Q1 Q2 by R square. So can I say this F is equal to 1 by R square, or F is inversely proportional to R square? This is a charge, this is a charge. If I say, for example, R is 1 in this case, radius is 1 in this case. So can I say in that case the force is coming out to be, for example, 1 if R is 1, if R is 1. Now if you double the distance, if you make R is equal to 2, for example, in this case, R is equal to 2 basically, understand? So in that case, what happens with this force? Put the 2 over here, this is 2 square, understand? So this will be 2 square, it will be 4. So can I say this F dash, new F, will be nothing but, that is 1 by 4. So can I say that will be F by 4 because this is 1 already. So that will be F by 4. So means force has been decreased by 4 times, understand? If you double the distance, force will be decreased by 4 times. So in that case, if initially it was 120 Newton, can I say what is the new force if the force is radius is doubled? So you will say, sir, that is nothing but F by 4. 120 by 4, that is nothing but 30 Newtons. So what is the correct option? That is B. That's great. Let's move on to the next one. The lines of force due to a charged particle. Come on. Always curved. Fine. Next one. SI unit of permittivity of free space. Come on. Permittivity of free space. SI unit of permittivity of free space. SI unit of permittivity of free space. I live in Kashmir. In Baramulla, exactly. Baramulla district, it's from the Tangmarg side. If you know it. Gulmarg side, Gulmarg side. Okay. Yes. Definitely. PES's life will finish all the 12 chapters as soon as possible. Definitely, yes. I am eagerly waiting for that. Okay. Seriously. I wanted to start that series. Even I told these people that we'll start this series, this one short series only, because I wanted. That's why. Okay. So we say permittivity of free space. Could you please tell me? See, we say F is equal to 1 by 4 pi epsilon naught. This epsilon naught is permittivity of free space. That is Q1, this Q1, this Q2 upon this R square. Understand? We are supposed to find the unit of this one. So can I say, if I take it over there, so it will be exactly for this one, just write it over here only. What is the unit for this one? You will say, sir, newtons. And this will be 1 by, this is a constant, forget about this. So this will be epsilon naught as it is. For this coulomb, so can I say coulomb square? And for this is R square, can I say meter square? Exactly in that case. Now do one thing, so can I say this will be epsilon naught will be exactly, that is this coulomb square upon this Newton, this meter square. Okay. Let's move on to the next one. Which of these is not a vector quantity? Come on. Thanks means a lot. Yeah, okay, I'll be sending you, I'll be putting up this in. Yeah, Gulmarg is called Switzerland of India. Can you send this slideshow with your notes? Yes, I will be sending this in our Telegram channel. Join that. Thanks means a lot. Okay. So, what about this one? What about this one? A, B, C, D. Which is not a vector. Okay. Captain Jack Sparrow. C. Akash C. Ullas C. Medhavi C. That's great. Now see, we say electric field. E is equal to F by Q. Okay. This is a vector, and split. Electric field has its direction. What is electric field? This is a charge at this point. What is the electric field? How much force will be experienced by a test charge if we bring it over here? So that will be more it experiences the force, more will be the field at this point. It has the direction. For positive charge, it's away from that charge, and for negative charge, it's towards the charge. So electric field is a vector. It has magnitude, direction. Dipole moment, P. This is a vector, okay? Its direction is from negative charge towards positive charge. This is a vector. Flux. We say flux is what? That is E dot A. We say flux is simply that is E dot A. Understand? E dot this A. Understand? This dot product of two vectors. Understand? In that case, that is coming out to be scalar. So this is a scalar. And force is a vector. Everybody knows, okay? So yes, option C is the correct option. Let's move on to next one. 2-point charge placed at a distance R in air exert a force F on each other. At what distance these experience the same force in any medium of dielectric constant K? We have two charges, understand? And in air, they are experiencing some force. They are applying some force on each other. If we place the same two charges in any dielectric medium, understand? In any medium. In that case, such that the force is coming out to be same. This is the first charge. This is the another charge. These two charges are applying some force on each other. They are in air. Okay, this is the air medium. This is in air medium. Now I'm placing the same two charges in some medium. Okay, over here, the distance between the two charges are different. What should be the value of that distance so that this is a medium? What should be the distance? What should be the distance between these two charges so that the force over here is same as the force over here in these two mediums? Come on. A, B, C, D. Which option is correct option over here? Tell me. Solve it as soon as possible. Can you tell me what is the correct option for this one? Everybody, I just want to know in the live chat. Waiting for your answers only. People, come on. I just need to know, man. A, B, C, D. Which option is the correct option? Now see, how can we exactly find the value of this one? If I say, for example, in this first case, the force between this and this is coming out to be, for example, I call that F1. How much you will say, sir, that is nothing but K Q1 Q2 by R square. If I say, for example, this is Q, this is Q, this is Q, and this is Q. Okay. So can I say this will be K Q square upon distance between these two is, for example, R square. This is R. And over here, when we place the same two charges in any medium, I call this as R dash. Because this R dash is different. We are supposed to find what should be the value of this R. Yes, C and D are exactly the same. Okay. So we say this R, what should be the value of this R dash so that the force between this and this is coming out to be maximum in both these mediums. Now, first of all, if, for example, we are placing the two charges in any medium, what happens with the force? Force decreases. Force decreases by dielectric constant times. That is K times. Understand? Force between the two charges. But this is dielectric constant. Hey, you might have studied this formula from your electrostatics. That is, force in any medium is nothing but force in free space upon that dielectric constant ER, or what do we say, EK. E or this K. K, ER. It is one and the same thing. Okay? Now see. So we say force in any medium means if, for example, we have two charges in air, they are applying the force on each other. For example, it is something. When we take the same two charges, we place it in any medium, water, glass, whatever it is. In that case, the force between these two charges reduces. Reduced by what times? K times. K is what? How much will be the permittivity of that medium? This dielectric constant is permittivity. Understand? What with permittivity times, understand, K times relative permittivity times. This relative permittivity basically tells us how much will be the force, how much force will be decreased in any medium as compared to the force in free space. Okay, I hope this you're clear with this one. So this is it decreases by K times. Okay, that's why I'm saying. Now listen to me very carefully. So can I say this F2? In this case, I'm saying, for example, force is F1. When we are placing the two charges in any medium, I call the force F2. So can I say in that case, this will be KQ square upon, and this will be R dash square multiplied by 1 by K, because force decreases by K times when we place the two charges in any other medium. Now the point over here is, can I say in this case, see, this is F1, this is F2. In the question itself, they are saying that what will be the value of this R and what should be the value of this R dash so that the force is coming out to be same. So means F1 is equal to F2. In the question itself, it is given that F1 is equal to F2. So equate these two. We'll say, sir, KQ square upon this R square will be equal to KQ square upon this R dash square, and multiplied by this 1 by K in this case. This will cancel over here. Now we are supposed to find this R dash. What should be the value of this one? Take it over there. This will be R dash square and this will be R square by this K exactly. So this square over there. So this R dash will be exactly R upon this root K. So this should be the value of this distance so that the force will come out to be same exactly between these two mediums. So this one and this one. Yes. Sir, please repeat once. No, I won't. Now see, what exactly I'm saying. These are the two charges, okay? I'm placing the two charges in air. The force is coming out to be something I call that F1, okay? In this case, F1. Now I'm taking the two charges, I'm placing in any medium. What happens with the force? By air mein force zyada aega. There is no hindrance between these two charges. When we place the two charges in water, glass, force will decrease because this permittivity basically creates its own medium. It creates its own field which decreases the interaction between the two charges. Simply बात सुनो, दो चार्ज को पानी में डालेंगे, force कम हो जाएगा. So that happens over here. कितने times कम हो जाएगा? You'll say, sir, k times f by k. If over here it is f1, so over here it will be f1 by k. So it will be f by k, for example. Okay. Now, find the force between these two charges in. You'll say, sir, f1 is kq by kq square by r square. Kq1 q2 by r square. Find the force between these two charges in any medium. You'll say, sir, kq square by r square and divided by k. By 1 by k likh raha hai na. So this is nothing but f by k because force decreases. That's why multiplied by 1 by k. Now f1 is equal to f2. Q, because it is saying that kya hona chahiye, what should be the value of this distance between these two charges in any medium such that the force in this medium f2 should be equal to the force in first medium. तो वहीं से बोल रहा है ये force इसके बराबर, equate कर दिया, simple maths done. Next question, come on. Okay, it is saying that, for example, if we have two charges over here, okay, such that the force between these two is, for example, this is q and this is q, force between these two charges is, I call this as f. If the charges is doubled afterwards, in the next situation we doubled the charge, I would say 2q, and this is also 2q, and we doubled the radius r. If I say this is r and this is 2r, what will be the new force? F dash किसके बराबर होगा? That will be f only na. Force will remain same, it will not change because you are increasing the charges also. See, in the first case you will say, sir, f is equal to, that is k q square by r square. Okay, q1 q2 by r square. In the second case you will say, sir, f is equal to, when you double the two charges, k, that is 2q, and this is 2q, q1 q2 upon r square, that is 2r whole square. Now this is 4 and this will be 4, this will exactly cancel, so f will come out to be, that is nothing but k q square by this r square. Ab dekho, exactly equal, so force will exactly remain same. Yes, that's great. Next one, come on, tell me what is the answer of this one. Come on, all of you. A, B, C, D, which option? Which option is the correct option? If E dot ds over a surface is 0, then electric field inside the surface and on it is 0. The electric field inside the surface is necessarily uniform. The number of flux lines, its field lines entering the surface must be equal to the number of field lines leaving it. Come on, A, B, C, D, which option is correct? Yes, exactly, C option is correct. It is something like the first question. If I say, for example, this is a surface, okay, the charge q1 is inside, q2 is inside, fine, and there is this q3 exactly outside. If I say, for example, integration of E1 plus E2 plus E3, understand? So integration of this one, E1 plus E2, that is electric field, this because of this one, because of this one, because of this one, and multiplied by that is this dA. Can I say this is flux? Will be equal to nothing but that is q1 plus this q2 upon epsilon naught. See, what is this? This is the flux q inside. This is something like this. This is the exact formula. E dot dA is nothing but q inside by epsilon naught. Understand? So this flux, according to the Gauss law, E dot dA is what? That is flux. So flux will be equal to, if we have a closed surface, in that closed surface, flux will be equal to how much charge is inside the closed surface times the upon epsilon naught. Okay, upon epsilon naught. If I say how much is the flux over here, you'll say, sir, how much charge is inside this surface? Upon epsilon naught will be the flux in this case. Same, that's what I'm writing over here. So can I say over here, this is the flux E1 plus E2 plus net electric field because of this one, because of this one, because of this one, dot A is equal to flux, that is Q1, Q2 plus Q3 by this. But I'm not writing Q3 over here because Q3 is outside. We have to take, this is Q inside. We have to take Q inside according to the formula. So Q inside is Q1 plus Q2 by epsilon naught. So can I say, if we talk about this Q3, so can I say in that case, the number of field lines entering the surface will be equal to the number of field lines leaving the surface because of this Q3. That means if E dot ds is 0, so over here, forget about, if I say for example, there is no charge inside, only the charge is basically outside in this case, only the charge is outside, that is this Q3. So can I say in this case, E1 plus E, kidhar gaya? Chalo, I'll just write this Q1 and Q2 also outside. Can I say in this case, E1 plus E2 plus E3 dot this dA will be exactly, this is Q inside. Q inside is what? Q inside is 0. No charge is inside this closed surface. So in that case, this will be 0 exactly. This will be 0, 100%. So can I say integration of E dot this ds or dA will be exactly 0. So can I say in that case, number of field lines entering the surface will be equal to the number of field lines leaving the surface. Number of field lines entering the surface, number of field lines leaving the surface. There's a logic behind this, okay? Next one. Find the net force on the charge placed at the vertex of the square. Okay. Now say the question is, for example, something like this is a square of length, for example, I would say R. This side is basically R. And you are supposed to tell me this is a charge over here, this is a charge over here, this is a charge over here, this is a charge over here. You are supposed to tell me what is the net force at this point, at this fourth charge. Understand? On this fourth charge. Option A is KQ by R square. Option B is KQ by R square into root 2 plus 1 by 2. Option C is KQ by R square into root 2. Option D is KQ by 2R square. A, B, C, D. Which option is the correct option over here? Come on. Which option is the correct option over here? Everybody. A, B, C, D. Come on, mark the options, man. Which option is the correct option? C. C is not the correct option. Come on. Anybody else? B. A. Okay. Let me just show you. This is a very simple question, not that difficult. If I say this is a force, this is a Q, this is a Q, this is Q, this is Q. Because of this charge, on this charge, the force will be something like this. I call that, for example, F1. Because of this charge, the force will be on this one. I call that, for example, F2. Because there are two charges, they will repel each other. This will repel. We are supposed to find on this one. This will also apply the force on this one. We don't have to talk about that. We'll talk about net force on this charge Q. Say this will repel this charge with a force F2. This will repel this charge with a force F1. This charge is also repelling this charge with a force. I call that F3. Now find the resultant of this one and this one. Add that resultant with this one. You got the correct answer. This is the simple thing that you are supposed to do. You'll say, sir, how do we exactly do that? Let me just show you over here. Listen to me very carefully. See, if we talk about this F1 and this F2, if this is R, this is R, this is R, this is R. Can I say this F1 will be equal to this F2? Why? What is this F1? How much is this F1? This is F2. That is, sir, K Q1 Q2 by R square. That is Q by R square. Understand? So in this case, K Q by same R square. So can I say this F1 is equal to F2? So I can say this F1 will be equal to F2 will be equal to K Q square by R square exactly. This is the first thing. Everybody? Yes. Now see. So this will be equal to this one. So can you tell me the resultant of this one and this one? You will say, sir, resultant of this one and this one will be this one. That is FR. Okay. So how much will be that? You'll say, sir, this FR will be exactly equal to, that is nothing but this F1 plus F2, F1 square plus F2 square. You'll say, sir, this will be F square because both are same, F1. So F square plus this F square plus 2FF and cos of, what is the angle between this and this? cos, you'll say, sir, it is simply over here. How much? That is cos 90 over here. Understand? So this exactly will cancel. So can I say this will be exactly, that is f root 2 exactly over here, because this is 2f square. F will come, square and root will cancel. This will be f root 2. So this f root r is coming out to be f root 2. Can I say it like that? Now, how much is this? How much is this f3? You'll say, sir, f3, I'll just write it over here. F3, I'll just write it over here. That is this. If this is r, how much is this distance? You will say, sir, this is r root 2. This is side is a. What is the, how much is the value? What is the value of diagonal? A root 2. Okay? Yes, yes. Okay, so this is r root 2 exactly. Long time no see. So we see this is r root 2. In this case, you'll say, sir, k q square upon r square. That is 2r square, because r root 2, its whole square, that is 2r square. Now add this one and this one. Both are in the same direction. Directly add these two. You'll say, sir, f net in this case will be f1, sorry, fr plus this f3. So what is this fr? You'll say, sir, that is f root 2. F is how much? That is kq square by r. You'll say, sir, kq square by this r square into this root 2, and this will be plus, that is this kq square by 2r square. So you'll say, sir, this will be exactly, that is kq square by this r square. It will be root 2 plus 1 by 2. Option B. Got it, man? I'm fine. You say, what's up? We are done with this. Was the last question. No, this is the last question. This is the last. Oh, we still have 3-4 questions. Sorry. Okay. It's not gonna take much time. Okay. Let me just tell you. For example, this is the another question exactly I have on the screen. Find the net electric charge of at the center of an equilateral triangle if Q charge is placed on the two of. For example, if I say Q is over here, Q is over here, can you tell me how much is the net charge exactly over here? Sorry, find the net electric field. Okay, how much is the net electric field over here? Understand? If I say, for example, net electric field produced by this is, for example, E is equal to 2 newtons. Because of this one also 2 newtons. How much will be the new electric field over here? Say, sir, because of this one, it will be, for example, 2 newtons. Okay. Sir, because of this one, it will be 2 newtons. So what will be the value of this angle? You'll say, sir, that is 120 degrees only. So in that case, because see, you might have studied vectors in your class 11. This vector is equal to this vector. We say angle is 120 degrees. So can I say in this case, this E net will also be equal to 2 newtons 100%. How? A E1 square plus E2 square root of E1 square plus E2 square plus 2 twice E1 E2 cos of 120 degrees, that will come out to be 2 Newton only. Understand? Okay. Okay. Annamalai. Is this Annamalai? Yeah, Annamalai. Come on. Now we have this chart. This was asked in JEE also. Okay. JEE also. So we exactly have this one. This is a charge Q. Okay. It is saying that we have divided this charge. Tell me, A, B, C, D. I want you people to solve this. Then only I will solve it. Which option is the correct option? Come on. Which option is the correct option? A, B, C, D. Come on, everybody, mark the correct option over here. Mark the correct option. A. People saying A, B. Come on, man. Everybody. C, A, B. Everybody like the session as soon as possible. That's mandatory. Everybody, all of you. So it is saying that we have a charge Q. Okay, this is a charge Q. We have divided this charge Q in two parts. First, I would say this is Q. And another one I can definitely say that is this q minus this q. Okay. This is a total charge. We have divided this. Now I'm placing this charge exactly over here. This is q, and this is exactly this q minus this q. It is saying that this is the separation between these two charges. I say, for example, R. What should be the value of this charge? How should we exactly divide? What should be the value of these two charges? How should we divide them so that the electrostatic force between these two is maximum? Understand? Force between these two is maximum. So we need to find the force has to be basically maximum in this case. What should be the value of the charge exactly? How should we exactly divide this? That is the question in this case. Everybody getting this one? Come on, I just need to know the answer. So you'll say, sir, simple. It is very simple. That is this df by this dq. Understand? Should be equal to 0. This is a concept of maxima and minima. Question for maxima and minima. This is a maxima. At this point, we say dy by dx is basically 0. At this point, dy by dx is 0. Basically, slope is 0. That's why we say dy by dx is 0. Okay. Now see, at what value of f? At what value of q, f has to be maximum. At what value of x, y should be maximum. Understand? So find that value of x where dy by dx is 0. We say, for example, from the concept of maxima and minima, if you want to find the maximum value, you find dy by dx is 0. At what value of x, dy by dx is 0. At that value of x, the value of y will be maximum. Same is the case over here. We have to find what that value of q at which f is maximum. Understand? So at that point of q, at that value of q, df by dq will be 0. Just differentiate this one. Find the force first between this and this. Say, sir, force in this case is nothing but that is k. This is q1 q2 by r square. That is q into this q minus this q upon this r square exactly. I can simply say it like that. So if now you need to find what? That is df by dq. So that is this df upon this dq will be simply. This df upon this dq will be simply. We'll say, sir, this will be kq, this kq, and this will be this q upon r square minus this will be kq square upon this r square. Now differentiate this one. You'll say, sir, it will come out to be with respect to q we are finding. So it will be k this q upon, sorry, this q where with respect to this q na, this kq and this is constant. Kq upon this r square minus, in this case with respect to this q r you are differentiating. So power down, power minus 1. So this will be 2k this q upon r square exactly. We can definitely write and make it equal to 0. So can we write it? Can we just write it over here? So this will be this will cancel. This c, take this and put it over there. This will cancel. So kq minus 2q. So this is kq minus 2k small q is equal to 0. So from kk will again cancel. So kq will be exactly 2q and q will be exactly q by 2. So at this value of q by 2, that is this q, okay? At this value of this q by 2, either it is maximum or it is minimum, okay? Either it is maximum or it is minimum. Fine. Now, how do we find this is maxima? Just find double differentiation d2f by dq square. If this is coming out to be negative, we say this is maxima. Understand? We say at this value of q, the force is basically maximum. So let's differentiate this once again. If you differentiate this once again, this will become 0. Okay, because we are differentiating this, sorry, this will become 0 because we are differentiating this with respect to q once again. So this will become 0. So it will be negative of, that is 2k by r square, 2k by r square. So this is coming out to be negative. So it is maxima. So option A is the correct option. Fine. Now we have the last question on the screen. Everybody, I just want to know what is the correct option for this one. The electric field due to a uniformly charged sphere of radius r as a function of the distance from its center is represented graphically by, come on, can you tell me? Can you tell me what is the option? See, you might have studied this. If we have a sphere over here, okay? This is a sphere. This is a charged sphere. Okay. This is a charged sphere. We say inside this charged sphere, from this to this, electric field basically increases. Understand? Till over here. This is a charged sphere. And when you go away from this one, electric field again decreases. This happens. If I ask you to tell me how much is the electric field inside this charged sphere, this is a charge distributed uniformly. This is a solid sphere, okay? I would say this is solid dielectric sphere. This is a solid dielectric sphere, okay? C. Yeah, that's great. Okay, this is a solid dielectric sphere. This is a solid dielectric sphere. C is the correct option. So this is a solid dielectric sphere. If I ask you to tell me the electric field inside, this is a radius r, okay? Means in that case, you'll say, sir, electric field inside will be nothing but that is kq upon this r square. What is this r? R is what? R is what? That is the distance. At what distance you are supposed to find? If I say, for example, at this distance, so this will be the R. So in this case, this is inside. This is inside. R is less than this R. R is less than this R. You might have studied this expression completely. There is a lecture available on this channel also. I have basically taught this in very detail. So then, electric field, I would say on this surface, it will be kq by this r square, simply where r is equal to this r. And afterwards, if I say, for example, electric field at this point, this is r. So in this case, electric field will be kq by this r square, where r is greater than this r. This is outside. Now what happens with the electric field? You will say, sir, from this point to this point, it keeps on, it increases. Understand? At this, it becomes maximum and then it basically decreases. So option C is basically the correct option, something like this, and then it decreases. When you go away from this one, imagine like it's a charge over here. When you go away from the charge, it basically decreases, okay? Yes, so option C is the correct option. From this, you can definitely make it something like this, okay? At this surface, it becomes maximum. From this center to this, it increases. Then at this, it becomes maximum and then it decreases. Next question is, you can follow me on JEE, on Unacademy. This is my username, okay? Yeah. So, follow me over there. Hit the follow button as soon as possible. Fine. Thank you so much, ladies and gentlemen. Is there any lady here? So, if you want people learn on Unacademy from country's top educators, you are supposed to join this plus and you are supposed to join this Iconic subscription, okay? Live classes will be available, weekly tests, unlimited access, structured courses, and in this Iconic subscription, personal guidance, test analysis, experts guidelines, study material, study planners. Next is, these are the prices for this one. Yes, thank you. PES's life means a lot, bro. Thank you. Okay, there are some people who keep on commenting, these are the irregular teachers. If there are only 3 or 4 students in the class, do you think we'll be motivated? Do you think, if, for example, you consider you are a teacher, okay? If you have 2 or 3 students on your class, in your class, sir, please take the classes for class 11 JEE regularly, sir. Now answer this, tell this guy. When we were taking this Fury live classes for class 11, there were only 3 or 4 students who appeared in the class, who used to appear in the class. At that point of time, do you want, still, we were continuing that series, taking the classes for you people. Okay? So, that's why we say you have to be regular. Then only we will be also regular. Understand? We'll be motivated. We'll feel like there are so many students who are waiting for us, who wanted to basically learn from us. You need to understand this fact. So, This is over here. You can take this IIT JEE subscription. No plans yet, bro. So this is do you study there in Kai? This is for 30 months, this is for 24 months, 12 months, 6 months, 3 months. So you can definitely use my code Yawar to get the maximum possible discount, okay? This is okay. Now these are the batches which we have launched recently on Unacademy. Yes. Tomorrow will be. So T20 test series, definitely you should go for this one. And this is for rank 1, 2 to 6, it is 3000. From 7 to 20, it is 2000. So use my code Yawar to get the maximum possible discount. Okay, enroll in this one. Okay, this is for enrolling. Okay, that's great. So this is IIT JEE Mega Combat. Use code Yawar to enroll in this one as well, okay? You can win up to 4 crore plus scholarship. Even if you get the rank, this is the way you can learn free from Unacademy. This is what we call the Mega Combat, Unacademy's combat, okay? No, I don't watch IPL, bro. Not into this cricket and all. Ask a doubt. If you have any sort of doubt, you can post it on Unacademy. You'll get the solution within no time. So thank you so much, ladies and gentlemen. It was all about today. See you guys tomorrow, very soon. I am from Kunzar. Okay, I am exactly from Kunzar. Kunzar, Tangmarag, Gulmarg, whatever you say, near Magam. And subscribe to this channel as soon as possible. Hit the bell notification so that you'll get the update every single time whenever we come live. New JEE channel is created. Just teaching in gym, bro. That's all I do. Okay. So thank you so much, ladies and gentlemen. Take care. Bye-bye. See you guys tomorrow. Bye. Heart from my side. Thank you so much. Thanks, Suraj. Chalo, bye. Take care.